the semantic problem, the ontological problem in manufacturing, the fact that every manufacturer has a wide array of different semantics, different labels for the data, and no place to find the ontological references, to find the links between knowledge, is the reason why we don't get this magical results bringing LLMs into our space.
Jonathan is an expert. It is such a pleasure to have him on this episode. What do you think about this one, Jennifer?
Oh my goodness, I love this one. I loved it so much. The thing I really like about this episode with Jonathan is he's such a practical guy. And I know that may not sound like a compliment right up front, but it's amazing to see this kind of a mind with this much experience.
Oh, for sure.
And the way that he thinks about, being really deliberate and intentional. And, you'll hear him talk a little bit about being intentional, about being that generational bridge in this age of, industrial AI. It's phenomenal.
There's so much clarity. I was thinking about, everyone says OT, IT knowledge, and there's like OT, I just know how to turn a screw, or OT, I know the depths of this machine. And then there's like IT, like I've heard of a database, and then there's like code, and like what really is a name versus an address space. And so like Jonathan has that next level clarity on both of these fields that I think very few people do. And so we're able to just like tackle these subjects. It's people are going to enjoy this one a lot.
Yeah. Phenomenal knowledge. Let's get into it.
Let's do it.
We're excited to welcome Jonathan Wise to the show, a veteran software leader and systems architect with more than 20 years of experience driving innovation at the intersection of industrial data, software architecture, and smart manufacturing. Jonathan has held key leadership roles at Rockwell Automation, Microsoft, Amazon, and GE, and today serves as Chief Technology Architect at CESMII, the United States National Institute for Smart Manufacturing. He's a recognized authority on contextual data modeling, digital architecture, and the use of practical AI to improve manufacturing performance at scale. In this episode, we explore how manufacturers are overcoming the data and systems challenges that stall digital transformation. From brownfield realities and legacy systems to semantic modeling and agentic AI, Jonathan shares clear-eyed insights on what it really takes to move from dashboards to decision automation. We'll dig into the cultural shifts happening on the factory floor, how organizations can build AI systems that don't hallucinate, and what the future of model-centric, AI-enabled operations might look like. Jonathan, this is a handful. We're ready to go. Welcome to the show.
Thanks for having me. I appreciate that nice introduction.
Yeah, absolutely.
And so, I want to dig right in. Jennifer gave that amazing list. GE, Rockwell, I think it was Microsoft, Amazon, CESMII, of course, now. Spanning everything from R&D and platform evangelism to leading this national initiative that I'm so glad we have. Like we've been looking for more and more of that. Jonathan, can you walk us through how your early work with web-based automation and system integration shaped the way you think about contextual data today? Really, like what key lessons from those years still guide your work?
I think that's a great starting question because I think about those early days a lot. I learned like IT software development in college, but then my first gig was at Rockwell Automation and learning about operational technology. And there was like a culture shock. Like this tech was clearly real and doing things, but this was not what I learned in college. It was this very different world. And the other thing that was fascinating as I look back about that time was it was also like the dawn of the web. And so some of my first projects were figuring out how to control automation equipment over the internet, which I later learned was very dangerous and nobody wanted to do that. But I was fascinated that I could like embed a control in a web page and start a machine and with like a primitive webcam from 1999, like see things happen. And those early experiments really have informed my career, the things that I still like to do, the bridge between IT and OT, these technologies that evolve down very different paths but need to work together, and the reality that our world has become more and more connected. I think those things were all formative and remain important.
Awesome.
Yeah, that's interesting. I mean, so fast forward that quite a bit to today. I mean, we know, we look at, kind of the struggle that manufacturers have had with connecting systems meaningfully? There's been a lot of change since. I mean, I was around at the advent of the web too, and there's been obviously we all know there's been a ton of progress. I mean, talk to me about that. Do they still struggle with connecting the systems as much as we all talk about that they do? Is that hyperbole? Is the data layer still that much of a challenge? And I guess talk me through a little bit about what you've learned about how to approach it.
Yeah, as you kind of went through the steps in my career, what's not obvious is there's a bit of an excursus there. So between Microsoft and Amazon, I kind of slid more towards the consumer side of things and IoT instead of IIoT while I was at Amazon. And so then my next role was back at Rockwell Automation, and that was 10 years or so ago. And I was shocked stepping back into the world how little had changed from like my first experience with OT in the late 90s to like mid 2010s. We're still dependent on RS links. We still had binary comms that depended on Windows communication technology, DCOM. The software still looked very much like what it looked like at the beginning of my career. They still look like Win32 apps. There were like attempts to modernize that didn't take off the way you would expect that they would, because in our space we're very conservative for good reasons. You need automation to work deterministically. You need it to be rock solid. You don't want like an OS update to take down your operation. So there were reasons that we had this parallel path of evolution. But it also means that it's harder to bring the learnings from like one path into the other, because they almost have to be reinvented. And we have these like big automation companies that each want to reinvent it for themselves as part of their ecosystem, as part of their platform story that encourages their customers to stay in their ecosystem. So there's like all these reasons, like some of them good, some of them cultural, some of them just like dumb reasons, that we don't innovate as fast in our space as we do in many other spaces. And that goes like all the way down the stack. The Purdue model, kind of this layered architecture where we bridge between the layers, also had good reasons for doing that. And some of those reasons hold up in a connected era, right? Like I don't want to be able to send a malicious command down through the layers. I want it to go through DMZs. But the corollary to that, the flip side to that, is it's harder to get between layers, and each layer acts as like a filtering proxy for the layer below it. Making it so that the data that I maybe once had, by the time I get to a surface where I can, experiment with modern AI, that data has been filtered out, or if it hasn't been filtered, it's been semantically mutated along the way. So it doesn't represent the reality that the folks who are actually interacting with the equipment understand. So yes, the short answer is yes, we still very much have those problems. It's not that we can't. You can do a POC quickly to show how I skip layers and get that out. But then to roll that out at scale, to roll that out consistently, to deploy it quickly so that it returns value to a manufacturing operation remains this brute force exercise where I'm either pulling the data I need through the layers and preserving and protecting its context very manually, or I'm centralizing, I'm trying to skip layers and unify the data so that it's all meaningful. And in both paths, it's a brute force effort.
There was a lot of good stuff there, and I want to pull on the thread of data structure a bit because I think you were saying the Purdue reference model is good, and there's a lot of logic to the point to point. And then you were saying at the end too about how it's so easy to prototype with AI, and I think that's one of the things that's driving this. Like, we're in a funny phase of the hype where it's like everyone like knows it's a bubble, but then goes back to bubbly behavior, but then calls it a bubble. Right?
not explore it.
Right. I mean, it's so cool to explore, and the prototypes are awesome. And then you can be, as you were saying, so far away from something that's scalable because that underlying structure is not exactly the Purdue reference architecture. So I guess say a little bit about that. Like you've said in some of your talks, Jonathan, that agentic AI is only as good as the structure beneath it. And you've talked about how in brownfield factories, legacy is the default, even with new machines, which I think is something maybe you could unpack. I think that's true, but like, what does that mean, right? So I guess the question really is, what are manufacturers getting wrong about what's needed to actually implement AI? Again, not just a prototype, as you said, but scale, right?
So really briefly on the Purdue model, it's not now a bad architecture. The biggest problem with kind of the passing between layers is one, like I said, the filtering, and two, it's the semantic mutation. It's the fact that the value offered at each layer kind of remodels the data. So
Mm-hmm.
even if the data makes it through, it's mutated. It takes a different shape or semantic uh, ends up with different semantic labels than the previous layer understood it as. If I were to go to a more hub and spoke architecture, like is popular with the UNS crowd,
Yeah.
so centralize the data, push it all to one place, I still have a semantic mess because each of these publishers may be talking about the same points of data, but they're talking about it differently.
Yeah.
So this effort to unify the namespace or drive consistent labels is good, but in both cases, this is this brute force thing. And this is what's critically important. When we talk about AI since, about 2022 or 2023, we're largely talking about generative AI and in particular large language models.
Yeah.
For years before that, when we were talking about AI, we were talking about a variety of different AI models, some special purpose for different tasks. And we need to understand AI is all of these models. LLMs are the hype right now. But we're going to get value out of all the AI models, and LLMs will just become another one of them. And maybe there'll be other models that people smarter than me will come up with. But in particular, for large language models, semantics are critically important. The apparent magic of generating text and responding naturally to text that we see in other spaces that we would love to have access to in our space is dependent on, or is dependent might be too strong a word, is informed and is definitely trained by a corpus of knowledge that has some semantic consistency, ontological references that it can follow.
That's a
So
good word.
in
Yeah.
in other words, what I'm saying is large language models were trained on the web. The content that's put on the web, largely in English, unfortunately, with these hyperlinks connecting these things, connecting knowledge across, is what makes LLMs appear magical.
Yeah.
And, there's differences in how we use words, but the training can weight according to how words are most often used. And generally, what we get out of LLMs seems pretty realistic. The semantic problem, the ontological problem in manufacturing, the fact that every manufacturer has a wide array of different semantics, different labels for the data, and no place to find the ontological references, to find the links between knowledge, is the reason why we don't get this magical results bringing LLMs into our space. I can do it once against one semantic corpus, one data set, one platform or one UNS, but I can't scale that or repeat it because everybody's platform has different semantics and everybody's unified namespace is their own unification. There isn't a consistent semantic across manufacturing, and there isn't a consistent place to follow the ontological references to build a knowledge base that can inform magical AI.
I hope this isn't too much of a distraction, but I want to know if everybody's always desired better standards, right? And then everybody fights about standards, and sometimes standards just become beholden to specific companies or commercial interests, or possibly countries even too. But usually, I think companies historically, right? And so, I think we would all be so much better off to have what you're saying, which is a standard at this higher level of that ontological data structuring. Do you think that's possible? I know part of this is the mission of CESMII, but how much of this is possible, and where do you see that?
Yeah, I think my thinking on that has evolved. I think in the early days of CESMII, we held out hope that there could be semantic standards, and there are ontological standards and that we could drive those things successfully into US manufacturing. ISA 95 gives us both semantics and ontological links, where if properly implemented, there is reliable meaning in an S95 model, at least for certain use cases. What we saw across 50 some odd projects that CESMII funded is that there is a wide array of sort of digital maturity. There are companies that like are serious in their internal unification efforts or in standards adoption and have the culture that can drive it, throughout their operations. But those are few and far between. And what they will inevitably find is that that's really hard work, that the standards aren't perfect, and that there's still going to be, unfortunately, room for interpretation depending on your stack and your vendors and the heterogeneous architecture of your system. And I'd say they're on like the far end of the spectrum. On the kind of median of the bell curve are many, many small to medium manufacturers who don't have people working on those things, can't translate those things to the kinds of value that they need today. And so if they have a digital transformation effort, it's not going to be informed by standards. It's going to be more piecemeal. It's going to be more grassroots or internal efforts where standards can help them. And this is kind of the shift in thinking that I've undergone, is that the standards need to be broken down into like smaller adoptable parts, like Lego blocks that I can swap into my architecture that begin to evolve me in pieces and parts towards standards. If we mandate like a complete standards adoption, the big companies may be able to do it, they may fail. The medium companies won't be able to do it at all, and the small companies are completely not going to be able to get it. So if standards are instead broken into these smaller, easily adoptable pieces, and we can unify our namespaces by like swarming toward a goal rather than mandating a top-down goal, I think we have a higher chance of success.
To connect the dots on that, would you see that like kind of like the profiles CESMII makes that might be about a specific process or machine, so they could focus on maybe the biggest thing that's driving their business and build around that? Is that kind of what you're talking about?
100%. So our corpus of profiles largely came from an organization called VDMA. VDMA is the European Machine Builders Association, and they've been on this same journey. So some of the companion specifications, the profiles built by these equipment makers, are 10, 11 years old, and they thought they could define truth for their type of machine and the use cases for their type of machine. And so we'll define this profile once and everybody will be able to adopt it. It turns out that is not true. That if you like offer a monolithic information model or profile, it becomes either take it or leave it, and most people will leave it. So they've also been on kind of this journey of how do we refactor, they call them machinery basic building blocks. How do we refactor into information model components? So I can adopt one component at a time, standardize how I understand the job state of my machine, or the energy consumption of my machine, or even just the identity of my machine, and be able to adopt these in individual building blocks. Kind of like the ISA 95 resource model is, I can implement different resources and begin to assemble ISA 95, but even more piecemeal than that.
Yeah, that's good work.
Yeah, and
then, I think that's got a better chance of succeeding than take it or leave it, top-down monolithic models.
Feels
and
like it. Yeah.
When you look at the future of AI, like it's going to have to, like it's. I mean, it has the opportunity to be a faster unifier in this space, but I want to talk about that a little bit. You talked about the emergence of this new divide. You talked about it at the beginning, pre-internet and post-internet, and we saw that there was a pretty big divide in the workforce, in catching up to that. And we're at the same point with AI, right? So, but AI has a better opportunity now with these LLMs to upskill people much more quickly into that space if it's, done correctly and thoughtfully. So that's literally some of the question I have. So when we talk about, that divide between those workers who grew up pre-AI and those who are literally still adapting to the agentic tools today. I mean, Andrew and I have talked about this a few times when at one of the manufacturing leadership conferences this year. I think you might have been at it, Jonathan. Andrew, what did they say that the percentage of the C-suite that's actually using AI right now?
Oh, well, yeah, there was a study they put out
Yeah.
of like how many are funding and supporting it. It's like a third or a half,
Yeah.
and then how many are using it in their own work.
Yeah.
And it was like 3 to 5% of C-suite, but the
Yeah.
one that just hit me in the chest was 1% of line supervisors.
Yeah,
And so I
exactly.
was like, who are they funding
Exactly.
it for when no one's using it, right?
Yeah, exactly. So then let's talk about that a little bit. What is the right way to bridge this cultural shift right now? Um, how do manufacturers, you just said like the number of line supervisors that are using it. How do we get that knowledge captured? How we get that and get it elevated rather than just replaced by tools?
One of the things that, and you kind of glanced over it, but I just want to call out, one of the things that LLMs are probably particularly well suited to is the semantic translation. So
Yes.
if there's a wide variety of semantic definitions and a target that you want to interpret that data as, LLMs actually can do that very well. It's the declaration of the target is, what do I want to translate to? What is the truth that I want to understand? Then LLMs can probably help us interpret the different data sources. But then to your other point, the people that we need to validate that interpretation are probably not digital native. They are the people who feel the operation in their bones. Like there's a story my manager used to tell me about at Rockwell, where he had a customer who would like put a screwdriver up to the machine, and by the sound and vibration, he could tell you what was wrong with his machine. Like he felt it in his bones. And if that generation is exiting, and we have this other generation that doesn't have these instincts, but does natively understand how to use these new tools, how do we capture that generation's knowledge? How do we capture their instincts and embed it into the training of these tools so that it can be accessible to the next generation? And in the same way, we have this, like, we need to bridge the OT-IT divide. We need to bridge this, like, the technology nativeness divide from the generation that understands natively how these machines work to the generation that understands natively how to interact with digital technology. And that is ontology. That is truth, right? The truth that one understands needs to be the truth that is accessible to the people who can use tools to access truth but don't know it themselves. And this, like the direct analogy is in vibe coding right now. Claude in the hands of a senior developer is an incredible accelerator. And I wouldn't anymore claim to be a senior developer, but I've had like enough runtime to know when Claude is spitting out garbage and when what it's produced is useful. I worry for a generation that knows how to use Claude but doesn't know when Claude is BSing, right? And so that's what we need to solve right now. And I can't say that I know how to solve it, but the moment is before us, where these tools are really awesome and really powerful, but they really need the knowledge that is in the humans, and unfortunately in our space, not well articulated into a training corpus for AI.
Yeah. Can I double tap on that for just 1 second?
Yeah, sure.
How do, like, in your experience, Jonathan, what's the best incentive to get them to want to do this? Like in my experience with some of our customers and some of my colleagues, it's, the AI, the LLMs, with the power of this, bring it in, have it be trained on the data. There's things like you don't have to spend as much time just documenting the training and like doing repetitive kind of stuff in that space. And then now you're talking, now we're getting a little more excited. Like, what are some of the ways that you can bring it to them that just makes it enjoyable for them to use it?
I think it's a good question, and I'm like nobody be accused me of being the most empathetic, so I might not be the right person to ask. But just from my own observations, the projects that CESMII's been involved in, and some of the ones that I'm involved in now, where there's a deliberate like structuring of the team to mix generations, to mix like backgrounds, and uh, kind of insist on a mutual respect for each other. So I'm in one of those projects with a major automotive, and they have deliberately mixed. There's like some real young blood, and then there's some, crusty old guys who've been around the plant forever, and a bunch of folks in between. Um, and it does require some empathy and some mutual respect to understand that they're like these two different perspectives are valid and need to come together. And I've put my foot in my mouth a few times and had to apologize to one or the other, but just like an intent to work together on this. I I and Yeah, I think that will help.
I like that.
That's a
I
funny
think that's
one.
right. I think that's
You,
right.
you maybe want to tell. So I'm sitting here in Silicon Valley, and I sometimes I angel invest and like coach new startups, and I saw this one. You just reminded me of it. It was. I hope it's successful. It was like built by this guy who's like a Korean immigrant, and you're talking about like different generations, and
Yeah,
it's the generative AI app where like the young Gen Z, Gen Alphas in the US are going like, "Hi, Grandpa Alpha emoji," like, "La la la, here's what I did," and it comes out the other side like, "Oh, blessed grandfather, let me tell you about this day," and,
yeah.
and then they write back, and it comes out
Generational translator. Yeah.
emojis and gifs. Yeah. And it's like, oh, they're talking. Oh man, yeah, I wanted. So, kind of going into that, you were talking about like before we were talking about like the use cases that get people exciting. We were talking about the challenge with generative AI where it starts doing BS, right? And there's this funny word for BS in generative AI, which is hallucination, which is
Right.
like maybe someone in San Francisco, doing some substances or something, thought this was the right word for this. I don't know. But it's kind of a funny word, especially like you think about like pre-machine learning at all. It's just like we have deterministic technology, it gets it right. And then with machine learning, we build a confusion matrix. Like, how confused is it, right? And now it's like hallucinations. Like, some ways the things is getting worse, but I guess what's like
It
maybe you
is.
could define hallucination too for anyone who's like listening to this and isn't already hearing this word all the time. And then beyond that, like I guess talk a bit about again hype and like AGI, artificial general intelligence versus just like practical promise of AI to avoid hallucination, right?
There's a guy that I worked with at Microsoft, he's quite prolific on LinkedIn, and when they did their deal with OpenAI, he's posting a lot about it. And I think it was before. This was definitely before I'd seen the word hallucination. But I like posted a screenshot of a bunch of BS responses from an early version of OpenAI, and he commented, "Yeah, hallucinations are a problem we have to solve." Um, and I was like, hallucinations. Yeah, that's a funny word for BS. And just the fact that these things like confidently produce it without, ever indicating they switched from knowledge to guesses. And there was this study that came out a month or so ago, hallucinations are not a bug. They are a feature
Yeah.
of large language models. They're designed um, to guess what word makes sense in the context. They're not designed to regurgitate information.
Yeah.
So the more like good information in there, the more strengthening links for that good information, the better the guessing engine will do. But when it doesn't find good links, it'll just find the next strongest thing, and whether it's right or not, that's what it's going to spit out.
Yeah.
And the reality is sometimes that's garbage, and that is how the system is designed. We get like better results by narrowing its context window, which you see when you're coding, or by augmenting the generation, like with RAG. And I'm much more optimistic about kind of narrow scope agents than I am about general AI. And I entirely think that AGI, at least on the technology evolution path we're on right now, is ever going to happen. Like, you can't take a thing that guesses for a living and elevate it to human knowledge. It's just a guessing machine. It's a word calculator, not a thinker.
Yeah, absolutely. So, it was a great point. It kind of takes me into the thought of, you've talked a lot about unified namespace. We talk a lot about unified namespace, right? So, and you've said, naming tags isn't the same as modeling meaning, and that a unified namespace doesn't deliver value without deeper structure. I don't think a unified namespace is a unified namespace without that deeper structure. For teams that are trying to move beyond dashboards into decision automation, and we often call AI just automated intelligence. I mean, that's what it is, right? Rather than artificial. It's kind of the same thing. But for people that are actually trying to move beyond just the dashboards and actually into like that automated intelligence, automated decision making, what does good need to look like under the hood for us to get to that point?
We interacted a lot with UNS kind of in its early days, and the interaction wasn't always positive. And I had a couple objections. One was to kind of the misuse, at least in application, of the word namespace. Yeah, an address space is not a namespace. What governs your address space is the namespace. And then the other word we objected to was the unified part. So basically, the whole label I objected to. Who's doing the unification?
If it's just software engineer, Jonathan.
Yeah, if it's just your internal team doing the unification, then it's not a unification at all. It's just your team's ideas. But in kind of more recent times, I've gotten a little more comfortable with it as being directionally helpful. It's a worthwhile exercise to sit down and look at your data and to begin to drive towards a common semantic. It's not a harmful exercise as long as you don't think that that's the end of the journey. You're going to need to unify beyond your individual team. You're going to need to unify with other teams. You're going to need to unify across plants, within your enterprise, across your supply chain. You have to build this largely semantic-only model with rules that other people agree to if it's really going to be unified. And that's going to require some definition of a namespace or profile or articulation of the rules that you all agree to follow. But like I said, it's directionally helpful. Even if you don't attempt a broader unification, it's still not the end of the journey, because the UNS, typically as expressed over MQTT, does not contain a knowledge layer. It's a semantic layer. And may have some structure within there, but you're limited by the hierarchical structure of the topic naming convention in MQTT and each payload, which could express a larger structure, but it's a structure for that payload. What we really need for the ontological layer or the knowledge layer is to be able to draw other non-hierarchical relationships between these things to understand how that data interacts. So like the simple example I like to give is if I've drawn a plant hierarchy in my topic structure and I'm publishing from the different assets in my plant hierarchy, that's one axis in a knowledge graph. It is not accurate to say that the operator of the machine is a child of that machine. I shouldn't draw the operator below the machine. It's not accurate to say that the material supplier for a machine is a parent of the machine. I could draw it hierarchically, but it's two different axes on this hierarchical spine. And as soon as I have a couple of different axes, I begin to have a graph. And this is why people talk about the knowledge graph, is I want to know the other relationships that exist. And a hierarchy is not a good way to do that. So we need to establish another layer. If you started with UNS, great. Jonathan Wise will no longer look down his nose at you for that effort. It was a good start, but don't stop there. You need to capture this other knowledge, these other relationships. And those relationships might also go to documents or videos or training materials or an AI transcription of the oldest guy in the plant's telling you about the top problem causes on this particular machine, right? We need to draw knowledge atop the UNS. We can't stop with the UNS.
Yeah, that was a great description. I know at Arch, we like to talk about maps, like, which is graphs and maps.
Map.
We have
Yeah.
like a factory map and a product map or a material map, and that kind of intersection
Right.
of those linkage layers. And like you said, now you can add leafs or connections to your map or your graph that are that piece of tacit knowledge, recording or a video, and things that didn't traditionally fit into the structure but are critical in this new way. I guess I want to. So you're describing that, and we're building up the complexity. And I like when you said, as long as I won't look, Jonathan Wise won't look down his nose to you when you've acknowledged like just having names isn't enough, and you need this linkage, right? And this is absolutely correct. And then it brings me back to earlier in the pod here, we were talking about mid-sized manufacturers and how critical they are. So some huge percentage are small and medium, and it seems daunting to build a unified namespace, and that's not even enough, and build these maps and graphs to do it. I guess, like, give us your perspective on what's the right entry point for AI readiness for these kinds of manufacturers. How would they think about standardization in a way that's practical versus paralyzing?
The way that we tried to do information projects at CESMII, and we learned some lessons along the way, but I still think that was a good approach, which might initially look like a pilot, and we've already said it's easy to do one proof of concept, but we deliberately only selected ones that were repeatable. So I would say a problem, a business problem or a performance problem that exists in multiple sites, solve that with AI. You'll probably start at one site, but it's going to require developing a namespace, a consistent semantic, a knowledge layer, an interface to that knowledge layer, and then trying and testing out appropriate AI models to solve that problem. But don't call the project done until you've repeated it at 2 or 3 other sites or two or three other similar processes. That's how I would tackle it. Is design for repeatability and drive end to end all the way through and repeat that end to end deployment, and then go after the next one and the next one. And throughout that process, begin to standardize, as well as the naming convention and the knowledge layer, the technology stack that you wanted to deploy. Go with a vendor. If you're medium, you're probably not rolling your own. Pick a vendor that you want to invest in and go on this journey with.
For sure. Yeah, really important to think about where you build versus buy. But I guess just the overall shape of that pilot recommendation reminded me of a chat I have with folks a lot where whether it's us or anyone else they're piloting a technology with, I say, like, why don't you consider piloting like 2 whole factories at the same time? And they're like, well, that seems like way too big. And it's like, no, you should take active use where you actually ask the frontline operators, the maintenance, whichever persona is using it, like have only a small set of them pilot it because you can't distract a lot of them, but still duplicate it in X lines and like test the data scalability. Right. And that's exactly why, because now it can't have been faked while you still get the distracting a small number of people to begin with.
Yeah.
And I think not everybody's clicked into their head that like, yeah, that's the right testing.
And a success metric for that should be that so I'm not interested in you accomplished it once. Yeah. I want you to accomplish it a number of times. And a success metric should be that each time you roll it out should go faster and easier.
Absolutely.
Or it's not going to be scalable.
Yeah. And then I actually want to take that to the next step then, Jonathan. I want to say, it's really hard to look down the road 5 years in the age of AI and have any sense for what that's going to look like. And, to be fair, I mean, if I look back over my career, I think I say every 5 or 10 years, I'm going to look back on this and we're going to be the pioneers that like slogged through that first bit and we're going to look back and we'll be like, that was so meaningful, right? And I think that we're in the exact same place with AI right now. So if I look at, if we can succeed on, like we've talked about, cleaning the data, getting these reusable models, some of these intelligent, the intelligent tools. What do you think factories look like 5 years from now? And I think even more importantly, what role are humans still going to have in that loop? We know that we have, a massive loss of this deep, career expertise in every region of the world, particularly here in the United States, right? What does it look like 5 years from now? What is the human role in it?
I'd like to be optimistic and say things are going to be better 5 years from now. I think things are largely going to be the same 5 years from now, except we will have lost some of the generation. What I would like to see, what I think is realistic in 5 years, is AI as advanced detection and recommendation. I don't think there's going to be many that are automating operations with AI. But if we can get to the point where AI is predicting, it can predict, I've seen it, can predict problems or optimizations and include recommendations that an operator can interact with to try those things out. I think that's success in 5 years. Maybe in 20 years, we're closing those loops. But even like my first AI product in this space could optimize like a control process inside a single controller, and operators didn't want it doing it automatically. They wanted to be in the loop. So I think that needs to be part of the human design. And that creates opportunities for kind of the generational handoff. When an AI pops up and says, I've spotted this problem and this is how you should fix it, or this is my recommendation to fix it. Yeah, creating the culture where the younger generation is validating that with the older generation, feeding that back into the model training so that the recommendations get better. That would be a good outcome in 5 years that I think is reachable and feasible.
Yeah, absolutely. I mean, you're speaking our love language, so that makes sense.
Okay, time for the rapid fire questions. Jonathan, is there a book, movie, or TV series that inspires you when thinking about the future of manufacturing?
I'd like to have something like super culturally relevant, but actually the most important book would be Eli Goldratt's The Goal, which was given to me at the beginning of my career and is still prescient and valuable today. Everyone should read it.
Great
cool.
one.
Yeah, cool. Okay, is there a leader or innovator that inspires you? Someone that's kind of shaped how you think about engineering, technology?
There's a couple of cool folks I work with in our space, but I think the stories that catalyzed me at the beginning of my career were the original Macintosh team. So I can't pick one, the whole team. And if you go read folklore.org, there's just these incredible stories about how this little team changed that industry by personalizing technology. And I still think little teams can do that today.
Awesome. What piece of technology outside of manufacturing has had the most impact on your life?
The World Wide Web. I wrote a paper when I was still in college after I'd written my first, at the time, very primitive web app. And we were like in the OS wars at the time. And I had this realization that doesn't matter. The web is the application platform. It's still true today. The web is maybe not what we wish it was, but it's the most influential technology of our time. Remains to be seen whether AI becomes the next wave or not, but it was built on the web too.
Okay, if you could instantly acquire a new skill or knowledge area, what would it be?
I liked learning. After I started my career, I did 4 years in seminary. I'm currently working on a bachelor's in psychology. So if I were just doing something else for fun, I think I'd like to learn to be a sommelier overnight.
Well,
that's a good one.
Seminary psychology sommelier.
That's a good one.
Jonathan, in a few words, what advice would you give to young manufacturing professionals who are listening to this, just, amazed by the trajectory you've had and the knowledge you have where you are? How should they think about starting out today?
Make it a goal to deliberately bridge divides. If you grew up with IT technology, make it your goal to learn OT technology and meet and understand those practitioners, and vice versa. If you grew up with OT, dive into IT technology, be a bridge. And then the same along the lines of our conversation, strive to be a generational bridge while we still have the opportunity to learn from the previous generation.
This was fantastic. Thank you so much for coming on the pod, Jonathan.
Yeah.
Thanks for having me. This was a ton of fun.
Yeah, it was great. Thank you, Jonathan.
Yeah, we'll keep following you and see you again soon.
Absolutely.
All right, likewise. Cheers, guys.